Working on a 2013 Chevy Suburban. Issue with this one is it's got that check engine light on. Right there, the cell, check engine light. So what we're gonna do is did a full system scan. So two codes in the engine computer, some of the liftgate, module, theft deterrent, driver door switch, passenger door switch, radio. Right. I don't care about those codes. What I care about is the PCM ones, because that's what turned that check engine light on right there. If I go to trouble codes, read codes, once it pulls up, sorry about the glare. In current in history, and our two codes are, we got a P0446, so that's Evap. Evap vent system performance, current code, last test it failed, this ignition hasn't ran, the mill requested, that's what turned that engine light on right there. Malfunction indicator light. And then you got a P015 Delta 00, heated oxygen sensor, delayed response, lean to rich, bang 2 sensor 1. So that O2 sensor controls bang 2 for the fuel trim. Slow response, probably the cross count issue. So to address this one, we may have to hook up an oscilloscope, do some tests, depending on what we find in the scan tool data. And then this one, we'll have to may have to hook up the smoke machine, depending on what we find. Do a purge vapor test on it and see if there's a leak, or it's the fuel tank pressure sensor, or go from there and see. But these haven't ran yet, these tests on this ignition cycle, but they have failed in the past, and that's what's turning the light on. So we're going to go to live data and go from. All right, so I got the service data pulled up for the first one, which is the 446 Evap vent system performance. To give you a general overview, so 446 is for Chevy, for this exact Suburban. Evap rate of emission vent system performance. Here's your scan tool data, fuel tank pressure. We'll look at all that. So circuit description, this diagnostic trouble code tests the Evap system for a restricted or blocked Evap vent path that would cause excessive amounts of vacuum to be developed in the Evap system. With the purge valve and the vent valves open, if the Evap system vacuum goes above a calibrated threshold, this test will fail. So on the engine up there, they have a purge vent, or a purge valve under the engine, or on the engine actually. And in the gas tank, they have a fuel tank pressure sensor that reads pressure and vacuum. And also back there in the fuel tank, they have a vent solenoid. So what they do to test the integrity of the system for leaks and stuff is when the engine's running, it'll close the vent, because the vent in the back of the fuel tank is normally open. So obviously your vapors can vent out through a charcoal canister and not hurt the atmosphere. That's normally open. If it wasn't, you'd have fuel vapors in your garage, wherever you parked. So that's normally open. But when it's running, it's doing a self-test. What it'll do, it'll close the vent solenoid in the back of the vehicle in the gas tank. It'll open the purge solenoid, which is pulse width modulated from the engine, or the engine computer. And when it's open in it, it's pulling vacuum. And then it shuts the purge solenoid valve for a certain amount of time, and it watches the fuel tank pressure, and there's the decay rate. And if it falls too quick or not enough within those thresholds, it'll throw this code. And it could be, I've seen where a bad fuel tank pressure sensor is causing an issue. I've seen where there's leaks. I've seen where the vent solenoid is not holding. So what I typically do is I look at the scan tool data for the fuel tank pressure sensor, which is, they call it the FTP. Make sure that's good. I do a purge and seal, watch the decay rate, and also, depending on what we find, sometimes hook up a smoke machine and make sure the purge and the vent's closed, and you can smoke it and see if there's any leaks that way. So that's what we're probably going to end up doing. But in the meantime, I don't have a whole lot of time today to troubleshoot this, but so conditions for running this DTC: ignition voltage, 11 to 32 volts, so battery voltage, barrel pressure 70 kilopascals, fuel levels 10 to 90%, startup engine coolant's less than 95, intake temp is 39 to 86 for the startup. The DTC runs, this code runs, or this check runs once per cold startup, up to 17 minutes when above conditions are met. So for this code to set, for the 446 to actually set, which is turn this light on, what has to fail or happen is the fuel tank volume is greater than 12 inches of vacuum for 5 seconds before 10 liters or 2.6 gallons of purge volume, or the FTP is less than negative 2.5 inches or more than plus 5 inches for 60 seconds after cold start. After setting the DTC for the first time, 2 liters, which is a half a gallon of fuel, must be consumed before setting the DTC for a second time. So that's the conditions. I know it's a lot right there. What we're going to look at is the live data to help explain that and go from there. Sometimes you can look at the freeze frame data to help you troubleshoot this. This is not going to really, I don't think it's going to help us too much right now. So if I look at the freeze frame data, freeze frame meaning at what, you know, conditions when it threw the code, engine RPM, fuel trims, coolant temp. So it threw the code at, you know, 154.4 degrees coolant temp. Fuel trims were looking real good, -2, -4% for short term. Engine speed was 1400. Vehicle's going 21.13 miles per hour, 39 degrees spark advance. You could use this to help the fuel tank pressure, 1.8 psi. But I'm not really concerned with this. Just something you could use since your first and last failure distance traveled. You could use that. But we're going to look at the live data for this. So you go to live data. We're going to go to Evap. So I got the live data pulled up. Evap, vent solenoid, key on engine running. The vent solenoid's venting, it says. And then if you look here, purge solenoid. So the vent's in the back, it's venting. That's the gas tank. The purge is duty cycled, pulse width modulated, right? So I can control that. It's 21%. And then let me go down here. Fuel tank pressure says -7. So that means it's pulling a vacuum right now. I don't know how it's pulling a vacuum when that thing's venting, but we'll look at that here in a minute. That means, I mean, it's pulling a vacuum, it's negative. And fuel tank pressure sensor is 2.25, which equates to that. 0 to 5 volt reference is equating to this. It's the same thing, just voltage versus, you know, your other reading millimeters of mercury. Let me see if there's anything else we can go in here and use. No, we're going to go now. What we're going to do is go to our active test. Back out of this. Active test. So you can do a couple things here. You could go to Evap vent solenoid. I could go to the back of the vehicle and I just turn it on and off. Make sure the vent is working. Which if it wasn't electronically would have an actual, you know, code for that. Which I can turn it on and off there. You can go to purge solenoid. And this is what I would use when I'm hooking up the smoke machine to check for leaks. I could use both of these. But what I'm looking for is the Evap purge and seal right there. And it tells you increase control duty cycle of purge solenoid and close vent solenoid. Seal closes purge solenoid 0% and closes vent solenoid. So we're going to hit OK. Actually, before I do that test, I have the key on engine off. And what I want to do is make sure my fuel tank pressure sensor is reading correctly. So if you look, key on engine off, fuel tank pressure 0.29. So what I want to do is I'm going to go and hook the gas cap just to make sure. Right now we're just atmospheric pressure, right? Just be no vacuum or pressure on it whatsoever. So if you look here, where are we at? Yeah, 0.3. There's like a specification we got to be within, but that's good. I mean, if you were way positive pressure, way negative vacuum, then that would be causing your issue. You would have a sensor that's lying to the system. But this one seems fine, so at least we know that's good. All right, so we're back to our active test, Evap purge and seal. Pretty sure we're gonna be hooking a smoke machine up to this one originally, or eventually. I mean, So now we're doing commanded state 0%. I can increase it, duty cycle there, and then system seal. We can seal the whole system, the purge and the vent, like you would, you know, if you're smoking something, or using a smoking machine for this one to check for leaks, which I think we're going to end up doing. What I want to look for right now, since we do some real quick checks, fuel tank pressure sensor right there, and that's all I want. So when I increase this should go negative. I'm at 10%, it's going negative. If I increase it more, it should go more negative. Increase it more, it should go more negative. And it's gonna start running like crap because it's pulling vacuum on that tank. If I go more, 40%, negative 25, 21, and it's starting to run like crap, which is what we want. That means we hypothetically don't have any leaks. Pop this open, I should hear a swoosh of air, which I did. I don't know if you could hear it in the video. Let me put this back on, redo it. And I'll get back in here. Escape back out, reset it. So what you're doing here is you're increasing the duty cycle of this purge solenoid up front, and it's pulling vacuum because the vent will be closed when you do that. So I'm going to increase it again. So if you look here, I'm increasing it. I'm at 40%, negative 23%, 20%. It's running like crap because it's pulling vacuum. It should not be venting now. It's not venting. Now it's venting because the computer just took over there. Let me get back here. Yeah, it opened the vent up, that's why. Let's get negative again. Get way negative. Not venting, venting. So it's negative there. You're gonna listen for a big swoosh. And I could hear it. I don't know if you can hear it in the video. Basically what that tells me is the click, good. What that tells me is at least it's pulling vacuum, because if it wasn't pulling vacuum, that means you'd have a hole in the system somewhere, and there still could be a hole, but this may be more of a restriction issue, and it would make sense that's more of a restriction issue because of, I mean, go down a lot of dirt roads all the time. Dirt's going to get up in the vent solenoid, up in the charcoal canister, and it's going to cause it to plug up, and it's not going to vent accordingly. And I believe that's the definition of our P0446 anyways. So now what I did is I hit the purge and seal, or system seal, purge and seal, then I went to system seal before we went increase. What it does now is it doesn't let it vent, and it locks it where it's at. So fuel tank pressure, it just locks it where it's at. We're negative 2.4 there. So now, I mean, hypothetically, you could smoke it if you had a leak. I don't think we have a leak. Like I said, I think we have a restriction in this evap system, so we got to troubleshoot that. So I believe it's like I said, I keep saying it, a restriction. But what you can do, we're going to do this quick test right here. I take this with a grain of salt, but ignition on and fuel cap removed. Verify the FTP sensor is between 1.3 and 1.7 volts. So key on, engine off. Go ahead and remove the fuel cap. Fuel cap's removed. I know we already did this test for the millimeters of mercury, but service data shows it in voltage, which equates to that. It's the same thing. So you should get 1.3 to 1.7 volts. Go to live data. Come on. And then we're going to go to evap. And then so 1.45, is right between there, so we're good. And I looked at that earlier. I just know if that's way positive or way negative. Then obviously your FTP sensor is good. So now what we're going to do is we're going to go ahead and do another test. We're going to put the cap on and run it. Then we're going to take and make sure the Evap vent solenoid valve is open. So the vent in the back by the gas tank is open. Make sure it's open. We're going to command the Evap purge to 100% and with the scan tool, and it should not go greater than negative 15 millimeters of mercury or negative 8 inches of water. It's the same thing. If we're greater than that, then you're going to have more than likely restriction, which would make sense. Cap back on, one click. We're good there. Go back up here. Start it up. And then we're going to go into our active tests. I'm going to go back again. We're going to go to purge solenoid. Should not go greater than negative 15. If it does, it has a restriction. Why should it not? Well, if the vent's open and you're pulling engine vacuum, it should just, pull through. Like, I mean, it'd be, I guess, a good analogy maybe, drinking out of a water bottle and having a hole in it. You can let air go through it. You can let it bleed through, where air is replacing the air that's being, vacuumed out of there. But if it's restricted, then like dirt in there, then of course it's going to have more vacuum because it's technically closed or restricted, even though it's the computer says it's open. But if there's dirt in there, it's a restriction. It's plugged up. So we're going to command it to 100%, but what I want to look for is two PIDs, parameter IDs here. This one, field take pressure, it should not go more than negative 15. And this thing should say venting. Where is it at? Right here. So it's venting. I'm going to increase this to 100%. It says venting. It's going to say venting all the time because I'm not changing it. But let me find my other one. I just lost it. Right here. And increase this to 100%. This should not go more than negative 15. If it does, we got a restriction. Because the vent's open. Look, it went to negative 22, 25, 28. If you go down here, we're venting. And it's running like crap. So that tells me there is a restriction. So that addresses the P0446. What we'll have to do now is go to the back of the gas tank, go to the Evap vent solenoid charcoal canister, see if that thing's plugged up, see if there's a restriction in here somewhere. That would be typically where it's plugged up at for this code here. That's typically what you see, especially since if you go down a lot of dirt roads, you'll actually have that. I know that earlier Chevys, Suburbans, and Tahoes, they had a service bulletin out, TSB, technical service bulletin, where if you drove down a lot of gravel roads, they addressed this specific code where you would have to replace that vent solenoid. And actually what they did in the service bulletin is they rerouted the vent hose in a different spot so it won't get so much dirt in there. I checked, there's no TSBs for this one, but I'm sure there's a restriction. So we just got to go through that, clean it, redo the same exact test, and then you can force it to do its test. You don't have to wait for the light to come back, and you can take the scan tool and force it to do its drivability test and go from there. So now the one we can look at next is the P015 Delta for the heated oxygen sensor delayed response lean the rich bank 2 sensor 1. So for that one, I'm going to go back to live data. Actually, before I do that, I want to see if there's any freeze frame data that's going to help us troubleshoot this, see what RPM it was at. Right there. It's in closed loop, expected because it's using O2 sensors. Engine temp 195, so it's warmed up. Short-term fuel trim on bank 1 and 2, 21%. Damn, that's very high. Long term negative, so the total is decent, but 1276 RPMs, 56.5 miles an hour. So ran for 14-15 minutes. So what we can look at is short term was 21% on bank 1 and 2. Long term is negative 14.21. So the total, you know, short term, long term total for that positive and negative 0. So that's good. That's on bank 1 is, you know, still off by what, 7%, still with under the 10 threshold. Because once Chevy, GMC, you get to positive or negative 25%, it'll give you a lean or rich code, which we don't have right now. But this is the sensor it's talking about, 2.1, 675 millivolts. It ran for almost 15 minutes. So let's go ahead and look at our live data. Alright, so our live data here, it's probably just a lazy O2 sensor. I mean, you could have, I mean, I've seen where exhaust leaks cause it, but this vehicle's too new and I don't hear no exhaust leak. It's probably just a lazy O2 sensor. But we can hook up, we can do some checks, maybe even hook up the oscilloscope. What I'm looking for is, or even if the heater circuit on the O2 sensor is causing, that could cause issues too, but you would have a code for that. Well, 1.1 and 2.1, these are before the cats. And what I want to do is graph these and compare data. So I'm going to set this to 0, 1, 0, 1. Merge these graphs. Sorry, I got to redo it. I put 0 to 1 volts, but it's in millivolts, so I got to go to 0 to 1,000 because there's 1,000 millivolts in a volt. So let me redo that. 0, 1,000, 0, 1,000, merge graphs. So what I'm looking at is bank 1, sensor 1, bank 2, sensor 1. So the green one is the one that has the issue at that RPM, not at idle, but at the 1300 RPM range. So 0 is meaning rich, or sorry, 0 is meaning lean, 1 volt or 100 millivolts is meaning rich. Anything below 450 millivolts or a half a volt, this line is considered lean. Anything above it's considered rich. Well, the code definition for this one said it was a slow response time from lean to rich. It took too long to go from down here to up to here at that engine load and RPM range of 13, 14, 1500, whatever it was. So that's your cross count. So you want to have so many of those in a certain period of time. Of course, when you rev it up, it's going to get more cross counts. You got more heat, more exhaust gases flowing. So your cross counts will be quicker. Eventually, when it catches up. There we go. Starting to catch up. So if we were stuck rich or stuck lean, we'd have a short to ground or short to voltage issue or anything like that. We could do some other tests, but I just think it's a lazy O2 sensor. What you could do then, because like I said, it's from down, the green one was too lazy from down here to go up to there. But if you look in the service data, my phone's about to die here. So we got the 015 Delta, which is this guy right there. Heated O2 sensor, delayed response, lean to rich, bank 2 sensor 1, which is this guy right, the green one. And you also want to look at, make sure your heaters are working for your O2 sensors, because you use heater circuits in there, so when you're at idle. But this wasn't at idle, this was a higher RPM range. But it's something you can look in the live data for if needed. We don't need that for this one. But if you go down here, so 05 Delta, signal performance, it's not a short or high resistance or none of that. So it's probably just more likely a bad O2. Talks about all the stuff I just mentioned there. But for that code to set, conditions for setting the DTC, go down here, The eCSIM detects that the heater O2 sensor 1 has an internal delayed lean to rich response when the voltage has not increased above 350 millivolts within a calibrated value of accumulated airflow. So we can look at that more with an oscilloscope, get some more accurate readings, look at the cross counts, look at some mode 6 data if needed, and then go from there. But that is it for now for this vehicle. We're just going to have to go to the vent solenoid in the back, see if that's plugged up, check all that out, get it cleaned out, and then redo the test. May need a new part back there. And as far as the O2 sensor goes, take that out, you know, make sure there's no exhaust leaks, you know, no vacuum leaks or none of like that stuff. But more likely it's probably just a slow response on the O2 sensor. And that'll be it for this vehicle. All right, I know I said it was done, but I did pull up the mode 6 data for the Chevy. So mode 6 meaning it's the tolerances, the min and the max, and that's when it throws the code. You can use it to help troubleshoot. But if I go to oxygen sensor 2.1, there's rich lean. We want lean to rich sensor threshold. Your mid, your tid, your min, your max, and your value in your unit. Everything's okay. But if this would turn red, I mean, it hasn't done all of its tested either. You could look at these numbers when it actually goes through its test to see where how much it's failing by. And then right now it's good, but it might, you know, we're not in the same conditions, so we have to do those same conditions test. But it's more likely a slow O2 sensor, slow response. So I just wanted to add that to it. So again, the recap: go to the back, look at the vent solenoid, make sure there's no restriction, clean it. May end up needing new vent solenoid. Look at the charcoal canister, do all that, redo those tests, and do the same thing with the O2 sensor. Take a look, clean it up, make sure nothing else is affecting it, and then redo the same test, and then that'll fix this vehicle. But that's how we kind of troubleshoot it, or one of the ways you can troubleshoot it.